Hello, welcome to Each One Teacher. Today we'll be focusing on the first chapter of IGCSE textbook, measurement. This is what we'll be learning in this video. Okay, so let's get started with the first topic, units and basic quantities. So everything that we have, everything has maybe there's a quantity, right? So to measure a quantity we use something called unit. So here they have given an example. Suppose you want to measure the width of a road. There are multiple units like meters, centimeter, kilometers, millimeters, inches, and so on. So we use instruments to measure an object. Like for in this case, we use a scale or measuring tape. So it depends upon what unit you are taking. So likewise, so there are three main quantities in physics. They are length, time, length, mass, and weight. Okay. So we will check this a bit detail later. So units for others are, for example, meter per second. So all these units are called, it's like a combined unit. Okay, so this is where these multiple units come together, and they make up this. So these are called derived units. Okay, this is derived units. So it's we say derived because meter is from the length, and second is from time. So likewise, so sorry, meter, so so length, time. So likewise, yeah, uh, there are units which are derived, and other ones like seconds, kilograms, mole, candela, then kilos, everything with ampere, meter. All these are other units. Here are a few examples. Seconds are the main unit of time. Speaking of which, there is different unit systems. So the main one that we all use is called SI unit. So SI unit is usually used to it's we use mostly all people use SI unit the most. And for kilograms we have V. Then for amount of atoms we have moles. For luminous we have candela. Then for temperature we have Kelvin. I think before I said something else, not Kelvin. Yeah, apologies. Then ampere, meter, and so on. Okay, now let's check the power of 10 shorthand. So this is the second topic which comes. So suppose you don't know much about power of 10 shorthand. Please check that video which is up there. Yeah, okay. Okay, now let's check this a bit more about this. So why do we need power of 10 shorthand? So we use this to simplify. It is more easier to understand using this power of 10 shorthand, and this looks we can write it more neatly. Okay, so we'll just check the different forms of number first. So we can say this 10 raised to 4, this is called exponent form, and this 10 into 10 into 10 into 10 is called expanded form, whereas this one 10,000 is the standard form. So here you can see how it's written. So here as you can see there's 3 tenths. Okay, so 3 tenths can be written as 4 is equal to 4 into 10 raised to 3, because there is 3 tenths. Likewise, so in math we have a topic called powers and multiples. So you can check that video also out. So in that video we explain a bit more. So yeah, so this is all you need to know for now. So if you want a number like 0.4 or 0.004, you can just put a minus, minus 3. So divide, it will be just the same as dividing it by 10 into 10 into 10. Length. So length is the next chapter we are taking. So length. So there isn't much to talk about this chapter. So anyway, we usually use a unit meter. Okay. Then so if you want to convert some unit, convert meter to some other unit like decimeter, centimeter, millimeter, all these things. If you want it, then you can just take that meter and it's multiplied by this. So suppose I want to convert 4 meter to centimeter. Just take 4 into. So if you check this text, you can see that it is 10 raised to minus 2. If you put into 10 raised to minus 2. So if you're using a calculator or something, you have a specific button itself. So doing this will show me the centimeter. Okay? 4 meter in centimeter. I can find it out like that. And 1 kilometer is equal to 10 raised to 3 meters. Significant figures. So this is a concept in maths, but it also comes in physics. Sometimes in the paper they will say there is they'll give a value at this on the right side, and they'll write 3 significant figures. So most of the time it can come in use. So anyway, so there are 4 main rules for significant figures. 1. All non-zero digits are significant. So everything from 1 to 9, all of these are significant figures. So 0 isn't counted as a significant figure. If it's like 10, 20 and all, yes, it can be counted as a significant figure. Okay. Then zeros between significant figures are significant. Suppose your number is 101. Okay. So here you can see that there is a 0 between non-zeros. This can be said as a significant figure. Okay. Yeah. Then so the short form for significant figure is SF. Yeah. So 0 to the left of non-zeros digits are not significant. Suppose your number is 0 to 3, and if you ask which are the significant figures, we can only say these are the significant figures, because this comes in the left side. Okay, so which isn't counted. This is just the same as 23. Okay. Last rule: zeros at the end of a number are significant if they are the right of the decimal point. So again, like how I said earlier, 10 and all those numbers can be counted as significant figures. So suppose your number is like 10 point, your number is like 10.056. So in this case, you can consider 10.0.56. That you can consider that 0 as a significant figure until and unless it is like 10.560. That 0 can't be taken as a significant figure. Let's go to the next topic: area. So what is area? So area is the amount of space it occupies or any particular shape. So and it always comes in the squared units, like we can say centimeter square or meter square. That's how it usually comes, because there's only two things in 2D figures, and in 2D figures only areas come. Okay, so area comes in only in 2D figures. Okay, so in this 2D figures there are 3 things that only come. There is width and height. Okay. Whereas if it is three, if it is, like let's say three dimension, then you will have, sorry, this is not height, this is length. So this is length and height. Okay. So here are a few formulas of some shapes. You can check that out. Yeah. So for this chapter, this is all you have to learn about areas. In maths, you'll study detail about it. Okay. Next concept, volume. The volume is the amount of solid space it occupies. It always comes in the cube unit, like centimeter cube, meter cube, all those. So here are few examples. So as you can see, breadth, height, and length. So I said in 3D figures, we have this three concepts. Mass. So what is mass? So basically, mass is the main content, inside any anything. Okay. So we can say mass of an object is a measure of the amount of matter in it. So it usually comes in the unit of kilogram, and this is not never anything by mistake. So let's stick with that. And for mass, you will have different formulas. We will learn about that in different chapters only. So okay, so this is our last concept, time and systematic errors. So what is time? So time is something which says that how much things excuse me for my spelling. So it is PHINGS. Okay, so how much things happen in a small period of time. So we use the SI unit is seconds. It's usually seconds. So we say meter per second and all. Yeah, and systematic error. So when we do measurement, there will be slight errors. Not everything will be accurate. If you're doing it with a scale or something, and there will be human errors and systems. Maybe they might have some minute. Okay, there will be some minute errors, which comes. So that is it for this video, guys.